I want to do is talk to you a little bit about what comes after the K through 12 student population leaves their academic training in at the sort of, not the undergraduate level, before they get to undergraduate level, when they leave school and come to university, things are going to change for them. And one of the things that changes is the environment, the students they're around. And what I'd like to talk about is really, the slides don't seem to be working. Is really how we're going to capitalize and how we're currently trying to capitalize on some of the really innovative things that are starting to emerge in that gosh, what do you call that? The K through 12 period of a student's training. And really go that next step. That is how to take the maker movement, for example, that the students are told a lot about, and really get them to think about how they're going to embark on creating an economic revolution. And that's one of the reasons why we're here at the Consumer Electronics Show, is the success our students have had over the last few years in really taking that next step. So what I want to talk about today, and we'll make sure we leave some time for discussion, is why do we need to have these things that you're starting to hear emerge in universities, and that is academic makerspaces. And is a makerspace really enough if we want to move beyond makers and really create innovators that have academic or economic impact? And if we have that as a goal, what are some of the resources that we at the university level need to provide, or perhaps it's even at the regional level, need to provide to make sure that this talent that we've spent so much time and energy on cultivating and developing after they've left the K through 12 period and come to us at university and really gained a lot of talent, how do we really make sure that the impact, the full impact of that training is achieved? So let's talk a little bit about why do we need academic makerspaces. And I think Stephen really laid, the gentleman from Lego, really laid a great foundation for why that is. And that is the importance of students to gain the experience of doing things with their hands, to seeing the connection between sort of the physical world and the reality that devices can be made and put together and things can happen through their labor. But it's a challenging opportunity in that if you think about the situation from my perspective, previous generations of students, and so I'm going to ask, how many of you are over the age of 40 in this room? Okay. So you're sort of my cohort. I'm about 57 years old. So this is, in my opinion, how previous generations of students who, for example, came to a highly technical university like Case Western Reserve, and from my cohort, the students of engineering are the ones I'm going to be speaking of, but you'll see in a little bit that it's not exclusively engineering students that I'm thinking about in this era of trying to get them to move from makerspace participants to really be people who are driving the world's economy. But if you think of my generation, sort of those who are over age 40, a lot of us sort of went into university with what I call hand skills. We were the generation of people who took things apart, for example, and I was certainly one of these kids. I took apart my father's lawnmower, my TV set, my radio, my record player, my cassette deck player, my 8-track tape player. Now I know I'm dating myself here, but I was one of those kids who did all of that stuff. And what I saw was motors and belts and things that turned, and I saw capacitors that changed, and I saw rheostats that changed, and I saw that when I changed this knob and I changed this rheostat, that the volume went up or the volume went down. And so I began to learn that there was a relationship between form and function, between component and role. And that was really important because that's what got me motivated to be an engineer, to go to Purdue, to go to Ohio State, and to continue on for a Ph.D. So I was one of these kids who took everything apart. And my premise is, and my strong belief is, most kids who went into engineering in my era and sort of after that went into it trying to and curious about what's the connection between all of those components we've been playing with, and what's the theoretical underpinning or design elements that would put them together to allow me to make a TV set, to make a radio, to make a cassette player. I sort of already had some basic understanding of the relationship of component and role, but what I didn't have was the theoretical underpinnings of how all of that came together. And so that's how I think a lot of, and I think one of the previous panelists talked about this, the reason why engineering and science education hasn't changed much is I think many educators in my role and in my faculty don't recognize the fact that students are coming to university today with very different experiences than them. They're not coming with those same experiences, and yet we're sort of teaching them the same way. We're teaching them the theoretical underpinnings, but we maybe aren't recognizing that they don't have those hand skills that I was talking about. And I think there's a reason for that, and that is students then versus students now don't really look all that different. The picture on the left is one basically taken from, not necessarily my collection of photographs, but a friend of mine. And if you look at the students, we're all basically wearing the same things. Jeans, flannel shirts, something like hoodies. You look in the classroom and you basically see yourself. And you have a tendency to believe that those students are just like you were, and they're going to learn just like you were, and they're going to develop and mature and progress through the curriculum just like you were. Unfortunately, that's a fallacy. And the reason is today, let's talk about our first year class, for example. Essentially, they were born in 1997, and when they were born, there were 100,000 websites on the internet. Dial-up speeds, the fastest internet speeds that were available were via dial-up at 56 kilobits per second. And today on campus, we easily have 1 gigabit per second almost everywhere, much of it via wireless. Google and Wikipedia, their most common source of information, was still 4 years away. They have grown up completely in an era where information was at their fingertips for their whole life, because YouTube, that appeared in 2006, and smartphones at the time, they're basically getting to the age where they're going to have cell phones. For their whole life, they have had unlimited access to information. And yet we as universities are oftentimes set up where the faculty member is perceived as and has the role of being the conduit of information. So I think you see the little bit the disconnect that we have here. So I think you have a sense of why I believe we need academic makerspaces. The previous panelists and the previous speaker, Stephen from Lego, talked about that, and that is we need to provide students the connection between form and function, between device and role, and yet there is no equivalent of the TV set for students today. If you go to the Samsung booth or the LG booth and you imagine taking one of those brand new TV sets available, you're going to find a circuit board. And the most you're going to do to repair that particular TV might be to replace a board. Now, if I take that board and look at it, there's going to be some custom integrated circuits. There's going to be some specific capacitors and things like that. But is a student or a learner today, before they get to university, going to understand the role of device or component and function like we were able to? Absolutely not. So we need to be able to provide students through Lego at the K through 12 level and in makerspaces like things at universities, the opportunities to get their hands dirty. And one of the things I say at CASE is, if I have a mechanical engineer that graduates who hasn't pinched their fingers in a pair of pliers and developed those little blood blisters you get when you've really, pinched yourself hard, I heard a couple people laugh, then I will have failed miserably as a dean. If I have an electrical engineering student who hasn't left and burned their fingers on a soldering iron, I will not have succeeded as a dean, because they need to understand that all of these things matter. So one of the first things we need to do in academia, and this is, I'm going to be speaking a lot from my experience as dean at Case Western Reserve University, a small private school, Cleveland, Ohio, with about 5,000 undergraduate students, about 5,000 graduate students as well. And of those 5,000 graduate students, 2,000 of them approximately are distributed across my undergraduate programs. I have about 500 students per year in each of my undergraduate classes. So one of the first things we did in my first year as dean is made sure we created classes where students could start building things as quickly as possible. And I actually have two of our students are here today, and so at the end of my talk, you can ask all of us some questions about what our experience has been like. These are some of the things we're going to talk about. But we've created classes where students can actually begin making things. Experiential learning, understanding the role between device and component and role. If I think about how are students different from us today, I'll share with you an experience of when I was at Purdue. So this would have been from 1979 to 1981, and I needed a specific book that our Purdue library didn't have. But what our Purdue librarians did is they wrote to the Ohio State University library system. Ohio State sent us the book by the mail, and about 2 weeks later I got the book I needed. That was called Interlibrary Loan. Now, we lived that, right? We were willing to sit and wait for 2 weeks because we knew that this reliable mechanism called interlibrary loan was going to deliver that information in a timely fashion. Can you imagine how ridiculous that must seem to Zyla and Tyler? Because they have grown up in an era where information is at their fingertips. The short period of time for a student today between want and have is incredibly short. They walk across campus, they want a song. They have it downloaded probably within 100 steps. They want a piece of information about a scientist, an underlying scientific principle. Again, Google, Wikipedia, they have that information. How ridiculous is it that our engineering and scientific curricula basically ask students to come to the university, they want to be scientists, they want to be engineers, they want to have careers and experiences, and ask them to wait to go through 2 years of pre-engineering curriculum where they take all their calculus, and they take all their physics, and they take all their chemistry, and they've not yet gotten their hands dirty, nor have they yet necessarily pinched their fingers or burnt their fingers on a soldering iron. This is a tremendous mismatch that we and others are trying to eliminate by virtue of the makerspaces. And us, like others, have a perspective is it's really important for us, just like at the K through 12 level, that you get students thinking about how do I get what's in my head and get it in my hands. We just did the exercise with the Lego ducks, for example. We each had an idea of what that duck should look like, and the tools that we had available for us in that exercise were Legos. And the K through 12 students are going to have Lego robots, and they're going to have other things. But what are they going to have when they get to university? We need to be able to, today, not just as they make it through the pipeline of the revolutions that you're going to establish, but the situation right now today is we need to make sure that the students have the opportunity right now today to take those ideas that are in their heads and get them in their hands. Now you may be thinking that why is Jeff up here giving this talk? And I think the reason we're here is about 3 years ago when the academic space opened up, we had 4 years of experience with our academic makerspace that I'm going to go into some more detail with. And in a short period of time, we saw that basically what our students were doing was using it in ways that we hadn't anticipated. Now, our first makerspace we called ThinkBox 1.0, and this had things like laser cutters, had printed circuit board routers, and 3D printers, all of the types of the things that are like the next generation of tools that you might imagine after a student finished their senior year of high school, went to university. What are the tools they're going to play with now? Well, you would hope that they would have 3D printers and laser cutters and all that kind of stuff. We provided about 3,000 square feet, and we basically just watched what they did. Now, while we in the School of Engineering have stewardship responsibility for this space, we didn't have ownership of it. And that is, by stewardship, this was meant that we were going to take responsibility to provide this resource to the entire campus. So our colleagues, our students in the College of Arts and Sciences, the math majors, the biology majors, the chemistry majors, students in the humanities, in music and the arts, for example, would have access to the space. And we sat and watched what they did, and we saw some really amazing things, and that was, there was lots of interaction going on between students who maybe didn't even know each other, but they were at least talking to each other. So this is the idea of interdisciplinarity. That is, that's certainly one of the things that we saw that we wanted to make sure that we establish as we move this initiative forward, to make sure that there were a wide range of people who are working in this particular space. Now, the second thing we noticed was actually a mistake on our part. And so I want you to listen carefully to this. The student workers that we originally hired to sort of work in this space that were originally selected because of their technical competence. The best students technically were the ones we originally hired to be the assistants to help out other students. Unfortunately, what that led to was situations where they would say, let me do it. I can do it for you. I can get this done for you in a second. And that doesn't necessarily create an environment where others feel that they too can succeed, where they too can go take an idea in their head and move forward. So we pretty quickly made the switch to hiring our student assistants based on their interdisciplinary skill, or their interpersonal skills, their ability to work with others, the ability to say, here's how you do one, let me watch you, let me help you. And that was a key change for us, was hiring the right type of people to be the ones who are going to be nurturing and cultivating this environment. As we did that, we basically expanded by about 1,500 square feet. And the reason we did this is, essentially, when we thought of it as a makerspace, we thought of it as equipment. What are the students going to need to make? And what we weren't thinking about is, what are they going to need to ideate? To actually sit around and talk and sketch and maybe play with Play-Doh. And we were influenced a little bit by Stanford's D School that many of you have heard about, but not completely. So we created an additional 1,500 square feet for just students to sit around and talk. And again, not necessarily just engineering students, but for them to begin and partake in their design. Second, I think we began being a little bit more overt about what's the difference between invention and innovation. And one of the things I always say to students, an invention is something you make, and an innovation is something people will buy. And so if you have an idea, that's great. Make it, have fun with it, get that experiential learning. But if you want to be the next Mark Zuckerberg, or if you want to be the next Bill Gates, or the next, founder of Pebble, or the next Steve Jobs, there's going to be, there needs to be a market there. And that is, you need to think about who's your customer, what's the product. But then, of course, that changes what resources I need to have in now what we had previously thought of as a makerspace, and begin thinking about it as an innovation space. And so my second statement is, I don't think a makerspace is enough. We really need to move past this idea of tinkering and really into the idea of entrepreneurship. Now, I also talk to students about the fact that the definition of the word entrepreneur has changed considerably over the last several years. Today, we really think of it as those people who are in startups and are, sort of out there on the first floor of this building and the Sands, the people who are really out there on the cutting edge, just trying to take that idea and turn it into a business. That is entrepreneurship, but there's also entrepreneurship in a large company as well, and that's using the available resources to their maximum potential, looking at what's around and seeing how you can leverage them and do things. And we've tried to talk a little bit more about not just being the next Steve Jobs, but also just being entrepreneurial as an engineer, as a student, as any kind of graduate of our university in whatever comes next. But again, that changes what has to be and what was previously our thinking of our makerspace. And I specifically, in talking to my engineering students, talk to them about the need for a broader tool set. And the way I do this is on the Friday before their classes start, the first day, or their freshman year, their first year, we have a big event where I have a chance to talk to all the students. And I ask them, that's engineering students, I ask them, how many of you were told you're good at science and math, you should be an engineer? And I ask them to stand up. And as you can imagine, virtually every student stands up. And I have them sit down, and I say, how many of you were told you're good at art? or you're good at oral and written communication, or that you're really creative. I've had one student stand up in 4 years when that was the criteria where an advisor said, yes, you should be an engineer. And yet, those of us who have worked in this profession know that these are really the essential skills. Oral and written communication skills, ability to appreciate art and design, that is, redefine engineer and designer. Think about how those two things come together. The ability to work in a team, and again, you heard Stephen and others talk about that this morning. It's not just, being able to build something, but also being able to capitalize on other people's expertise. When I think of how I train my mechanical engineering students for the most part previously, or my electrical engineering students, they're working with other electrical engineering students, and yet when they graduate, they're going to go work with mechanical engineers and chemical engineers and all kinds of people. So this idea of interdisciplinarity is something that we really need to reinforce and continue from what they're going to experience at the K through 12 level. But they also need to have a sense of business sense. That is, what's the economic model of this idea that they have that's an innovation? So there's a wider range of skills and network that the students need to have beyond simply their own personal contributions to a project. So if we change the definition of what we're looking at then from makerspaces to sort of entrepreneurial centers, I'll tell you a little bit about what we did at CASE, and it's the Larry and Sally Sears Think Box. So I talked about 1.0 and 1.5 versions of this. We've actually expanded this quite a bit further. So we started off at about 3,000 square feet. We expanded to 4,500 square feet as we went from makerspace to making and design and collaboration kind of space. But as we really began thinking about this as an economic driver, or really an entrepreneurial center, and I think about all those 6 or 7 other skills I talked about, we really realized we need to think about this space differently. We really need to think about it as an ecosystem. Now, the reason I talk about this as an ecosystem, and I have this picture from the rainforest, is the way I think we've been thinking about engineering and science and STEM and STEAM education in the past is more like a cultivated field of corn, where there's row after row of very similar kind of plants that are emerging from this fertile environment. And yet, for us to get the most out of the talent of these students that are coming to university, we really need to provide them an ecosystem where their skills, their attributes, what they can bring to play really is what we're trying to capitalize on. And so what we've done is we've taken an old 49,000 square foot building and converted that into the current version of ThinkBox. So this is the largest design and innovation space on a campus, at least in the United States, if not the world. And we set it up in some ways to model and parallel what we talked about previously in terms of some of the lessons we learned in our 1.0 and 1.5 version. We still have space for them to collaborate, but it's a large space, highly reconfigurable space, where there's hundreds of students can collaborate, because I want that ecosystem of students who are collaborating together to be as robust as possible. We work very closely with our School of Management, our School of Law, and a nearby, the Cleveland Institute of Art, which is nearby, to bring in students and faculty from their industrial design program to work with us. Again, my ecosystem has to be as broad as possible. Further, I make it so that any student from any university or school or person off the street can come in and use these facilities. Anybody. It's open to anybody. So what does that mean? So if I think of Tyler and Zyla, I don't know if their next employee needs to be someone from our School of Management, our School of Law, or a technician from a local community college. I don't know. But I know I can help them out if the ecosystem affords those people the opportunity to come in and play, to be part of the asset mix that has availability and opportunity to use these particularly unique resources. Now, I said before, we're a private university. We have basically funded all of this ourselves. We don't get money from the state for this, although our state of Ohio just gave us $1 million to finish up some of this building. So let me go through some of the upper levels of this particular building. On the 6th, so it's sort of laid out as sort of a progression. Students are going to collaborate, they're going to ideate on the second floor, they're going to do some prototyping with 3D printing and that kind of stuff. Maybe they're going to use a printed circuit board router, maybe they're going to use some materials and laser cutters or things like that. Maybe they're going to do some coding, who knows what they're going to do. But that's really that first level kind of stuff is going to happen on the second and third floors. As they really get serious and start thinking about how are we going to make this thing, the resources to do that are basically on the third floor. Now, when I talked before, I said, I want students who can take ideas and think about taking ideas in their heads and getting them in their hands. And I found myself even saying that, get it in their hands, and I would sort of do this. But what if that idea they have is this big, or this big? Or what if it's, the next Tesla? I don't know, but I need to be prepared to have spaces that are highly reconfigurable and will adapt to the types of projects and clubs and organizations on campus. And I think the Stephen from Lego mentioned, get students, at the K through 12 level, get the students involved in clubs and projects and things like that, because that's exactly the kind of things we're going to ask them to do when they're in university. Now, I'm going to give you a very interesting aside here. And it's a little bit of the dynamic tension between a student and a faculty member, and in particular, a student and a dean. So students will come to me all the time and say, we're really active in our Baja car or our Rocket Club, and we're so active in that we should get academic credit for those experiences. And they are working really hard, and it's impressive the work they do. I encourage you all to go down to the lower level of the Sands where we have, I think, 12 booths or something like that of our student startups and our alumni startups from the last couple of years here at the Consumer Electronics Show to just see the kind of stuff they're doing. But I also know that the students who are interested in having that kind of career probably only represents 20 to 30% of the students. The other 70% of the students actually want to probably just go get jobs. Maybe they want to go to graduate school. So I can't gear this specifically and exclusively to students who want to go out and do their own business. I really have to also be thinking about other students who want to go on and basically just go get a job. Maybe they want to work for Intel or NVIDIA or Apple. And then what they're going to get asked in the interview is, what have you done? Not what grades did you get, what have you done? What have you made? What have you done? And when that question is being asked, they're not being asked, what did you do in a class? They're being asked, what did you do on your own? Where are your passions? And if I give them academic credit for those clubs, they can't talk about all of those things they did for their club in an extracurricular way. So anyhow, it's just sort of an interesting thing. So that's our project space. The entrepreneurship space is basically where we have brought in basically assets from around the entire campus to serve in this role of an entrepreneurship center, an innovation entrepreneurship center. So for example, our law school has an intellectual property ventures clinic run by a couple faculty members and students who want to go into IP law. They help out students who have this particular entrepreneurial bent, and some of the students here can talk about that. We also have a club on campus in our Weatherhead School of Management from students who basically want to help do or want to do launches and business law. So we have students from our entrepreneurship club who have their offices of that club on the 6th floor of the building as well. We have a program called LaunchNet, which basically, from the first day a student comes onto campus, if they're one of those students who wants to be an entrepreneur, they can come into LaunchNet and basically gain access of faculty and adult mentors who will introduce them to our network of venture capital people, prior CEOs of small and large companies, to help the students refine what their product really is, to ask them questions about how are you going to make it, where are you going to make it, how much is it going to cost to make, how much are you going to sell it for, and help them understand the market side of this product, this innovation they have to do with. So these are the types of services we're providing on the 6th floor. And the last floor is basically the incubator space. Now the 6th and 7th floors aren't open yet, but we're providing those services already within this existing environment. So you can see in our experience that we didn't overrun the supply line. we basically watched how students were using these kind of assets that we were providing them and make sure that we were evolving and responding in ways that were supporting them and allowing them to help us, or we were asking them or having them help us define what that next set of assets were going to be. That's why we brought in other components of the university and the environment. So this is what the space looks like now. This is a Sears ThinkBox. It's 7 stories. It's 50,000 square feet. Like I said, we're a small university, and this is at least twice the size of anything I've seen so far. And it's interesting to look at who's using it. And as I said before, I'm the Dean of Engineering. I have responsibility for stewardship here and making sure that this is broadly a campus and regional environment. About 13% of the people who use it are graduate students. 15% of the students are kids from the Cleveland Institute of Art, a completely independent institution that's a couple hundred yards down the road from us. But it's creating that mashup between engineers and science students and humanities students, marketing students, where they're now creating sort of this positive feedback situation where they're all working together. And yes, of course, 59% are undergraduate students, but that's what we want. We want them to be able to come to the university and get those experiences, that experiential opportunity, but also to not be stopped there. They need to have the ability to go beyond that. So every key right now, you may have seen some stuff on every key. Every key basically is a way to have a device that stores all of your passwords, all of your information, so that when you go up to your laptop or your cell phone, it automatically unlocks. When you go to a website for your bank, it automatically unlocks your bank. Every key, actually, John McAfee, the antivirus and security guy, is down in their booth today. They've hired him as a spokesman. This is one of the first projects that we brought here to the Consumer Electronics Show about 3 years ago. There's other things, the Pro2Fit inspiratory muscle trainer, student ideas. Apollo Medical Devices has gotten a lot of attention here. They're here for, I think, for the 2nd year. This is basically a single drop blood point of care testing device where, for example, instead of just getting your blood glucose, you can get 8 to 10 other parameters measured virtually instantaneously, okay? There are countries of this world that will never have landlines, okay? And when I say landline, I mean a regular telephone line that many of us are used to have, because it's cheaper for them to provide a cell phone network than it is for them to provide landlines. The challenge then is, in many of these countries, is the electrical system is sufficiently unreliable that the charging of their cell phone, which is actually how not only do they communicate, but it's also for microloans and banking and e-commerce and things like that. The challenge isn't the wireless network, it's the ability to keep your phone charged. And so a very awareness of what the world market is allowed another company, Greenlight Technology, to emerge. And I think they've won over $300,000 in US EPA and Department of Energy grants to commercialize this technology. And there's other really cool things. And the reason I bring this one up is this is an example between some students in the Cleveland Institute of Art, students in our electrical engineering department, and others, where they, by virtue of the interactions in this ecosystem, came up with some really cool ideas of what the next generation of fashion looks like. And you've seen some similar ideas here at the meeting this year. The plasma-assisted fuel nozzle. The #1 expense for airlines is fuel. If you could save airlines 0.1% in fuel costs, it would be $1 billion. If you could save 10%, think of what that would be for carbon emissions and all those kind of things. So the student whose this project was just named one of Forbes' 30 under 30. All of these projects were done in this ecosystem that I was describing a moment ago. And what we've done then is basically taking our things, as I said before, not just from our university like ThinkBox and our LaunchNet program and our IP Venture Clinic and our Weatherhead School of Management Fusion program, but also partnered with that in working with the Northeast Ohio Regional Economic Development Organizations to make sure they're aware of and participating in the activities and reviewing the projects that are coming out of this. So what comes after ThinkBox? So I think you see how you can do this, but just the ability for a student to think of how to actually do the business, they still are perhaps left with the ability or the question of how are they actually going to make their product? And I think one of the things we have to think about is in the case of Every Key and Apollo Medical and Greenlight and FGC and Hive and others is great examples of the 21 students we have here at the Consumer Electronics Show today is how do we make sure that they can actually make their product, make it and sell it, okay? And so one of the things I'm thinking of an awful lot right now is not how to just provide the assets from my region or from my region's economic development organizations or my assets from my campus to this particular program, but how do I connect them to supply chain people? How do I connect them to people who can make the circuit boards or make the housings, and to do that in such a way where if it makes sense to go to China, it makes sense to go to China. If it makes sense to go to Korea, it makes sense to go to Korea. If it makes sense to go to Elyria, Ohio, which is 5 miles away, that makes sense too. But I need now, my biggest question that's going through my head now is how do I connect them to that next step in this whole process? And that's really a thinking about supply chain and that kind of stuff. So what I'd like to do now is just, I promised you before I'd make sure I'd left time for questions, and that's really where we are now is, you know, I think there's a lot of really neat things that are going on in higher ed today. And these makerspaces are really important because it does fill that critical role of giving students experiential learning opportunities in a cohort of students who haven't yet had the Lego robots and the other things that were talked about in the sessions before this. I think it's going to be a while before that permeates the students who come to higher education. We need to provide those experiences absolutely right now. And so that's one of the things I'm thinking about. But I want it to be more than tinkering, because I think there's lessons to be learned there. Because tinkering is sort of inventing, and inventing is great, but there's also the economic value of sort of thinking about this in terms of innovation. And that is, you know, as I said before, an innovation is something people make. I think there has to be this entrepreneurial component to it. Because when I came in as dean about 4 years ago, I went out and I talked to 100 companies. And I said, what's the one thing that you would tell me about engineering education and STEM and STEAM education in the US today? And they all said that basically our kids are great technically. Technically, engineering, science, they're really good. Where they don't have as good a strength is sort of understanding the business case, being team players, being good at oral and written communication. And that's why I think this entrepreneurial component has to be there as well. You know, these guys, for example, to hear them give their pitch is really impressive because they're good at oral and written communication now. You know, they've had to develop that skill, just like they've developed their technical skills as well. And as I said before, if we really want to make these centers really achieve their full potential, moving beyond tinkering and maker spaces and really moving them to entrepreneurial centers means that we need to provide connections even beyond those we've thought about already at Case Western. This is a really interesting time for us in higher ed to make sure that the value add that we're providing is far beyond those types of things you could get from a MOOC, things that you could get from studying at home. It's really about ecosystem and other types of activities. So at this point, what I'd like to do, I think this goes backwards, sorry about that, is just open it up for questions. We have a couple of students here who are willing to share some of their experience as well. So I would just like to thank you for your interest and your participation and attention. Thank you very much. Yes? I'll repeat the question. How's that?
How do you do that in 4 years, given that you want to have the interdisciplinary skills? Students now, traditional engineering education is mostly focused on math and science. But if they're going to have more oral and written skills and other types of skills, how can you do that? And wouldn't the entrepreneurial activities also require some business knowledge and so on? Not that they couldn't have clubs and so forth that would be outside of school, but seems like a 5-year education.
So I don't know if I agree with that, with the 5-year education stuff. But what I will say is one of the things we've done is introduced first-year classes that are all about oral and written communication in engineering topics that include design and build. So that right away gets them thinking about engineering topics, speaking about engineering topics, evaluated about their oral and written communication skills. We call these SAGES classes, and these guys are sort of smiling. In the SAGES class that I teach, and it's rare, I think, for a dean to teach, but in the SAGES class I teach, it is all about getting to the point where student teams, so again, now we're talking about the interdisciplinary teamwork side of things, it's important in their engineering curriculum that they have team-based projects where they are working together. So senior design now for us has moved away from individual senior projects to group senior projects. And then the group sort of typically evaluates each member of the group. So I think it can be done. It's hard. We're also looking at completely revising our engineering core curriculum that happens in the second year to incorporate leadership and some of these other things. So it's hard, but it is possible. Yeah.
I noticed on the slide that about 15% of the people that that go to your facility were faculty, staff, and alumni. Do you encourage the faculty to really become engaged? Because that's the biggest challenge of being in the academic setting.
Yeah.
You're busy teaching and mostly going to meetings, and that entrepreneurial aspect seems to get lost. Can you talk about that aspect of encouraging the faculty?
We've hired some specific faculty members. Malcolm Cook, who went home this morning, for example. We have hired some specific faculty members to have responsibility to work in the space, and others have sort of taken it upon themselves to make sure that they're using ThinkBox as a resource for their classes. So I didn't make this perhaps clear. This is not a teaching lab space at all. There's no classes that are taught in there right now at all. This is really a playground, a sandbox space for students to go and do what they want. Now, that said, it's a really, really big space where we can have, and we're encouraging our faculty to have their students go do their projects, their group projects in that space. And that's sort of what we're seeing now. And it was important so we just opened the new facility, the new space from the 4,500 square feet in October. And so we're right at that transition where previously we had no space to do that. And now we're starting to see those student teams and projects starting to gravitate over there.
A question over here, right here.
Okay, yes.
Hi, I saw that you had, I think you said 5% of community members were using the space. Mm-hmm. And I'm curious as to how that is actually implemented. Do you have an awareness campaign in the community? Do they have to be interviewed by staff or alumni? How does it get reconfigured if they have an idea? Is it kind of like the Small Business Development Center, then they come in and they have a counselor?
Yeah, so basically the way it works is the student stuff always comes first, and we are an academic institution with, students and faculty who are meant to be there, and it really is a resource that's primarily intended for them. So they are always going to have priority. However, with as many assets as we have, basically as with the community research or the development efforts that we've done in terms of awareness, what happens is members of the communities will come in, they'll either talk to the faculty member I mentioned previously, Malcolm, or talk to the manager of the center, tell what their interests are. We explain to them that while it's open and accessible, it's not free. So they have to pay for the resources that they consume at sort of the going rate for outside people. And then we make sure they're trained, and then we schedule them. So the scheduling will be after typically the student work is done. But it's been a really interesting program.
So a business would come in and
Yeah. Not so much. But we do have some really interesting K through 12 programs, for example, that we're doing in the summer and we do throughout the year, where our student clubs work with nearby high schools and other programs to bring them in as well. But we typically do those kind of things on Saturdays and sort of typical off times for students. So, there's a lot of stuff going on. Yeah, back here.
Hi, my name's Hank Bryan. I'm the Director of Innovation and Technology at the Hillside School. We're a nonprofit middle school, and we have something similar to your ThinkBox 1.0 at the current time. My question is, what do you think the potential is for a middle school level innovation lab or entrepreneurial lab to move toward this changing, Makerspace to an entrepreneurial center, like creating these producers of innovation, invention, at our level? What can I do for my students?
So to answer your question, I'll share with you that we're putting together a program where we're going to offer that at the 9 through 12 grade level in the summers, and we're going to offer it internationally because we know there's a demand for this because it's a hard thing to do. I thought the stuff that Stephen from Lego was talking about was really interesting about the idea of scale up. What's the idea? So the exercise, if none of you were here, he had us make a duck out of, I think it was six Legos. And then he showed that once you get to the point where there's some consensus about the design, everybody in your row could make one. And so that's the idea of scale up. And then everyone in the room, if we all agreed on that, that would be mass production. I think those are the kind of things that you can do to bring in principles other than just making. And I think also students trying to get them to move from invention to innovation, and that means they have to go talk to people. So have them talk to their neighbors, have them talk to the grade above or below, and ask them, would they pay for it? How much would they pay for it? That kind of stuff. Those are easy things to do, and it gives them the sense of whether they have the idea right. When I did this with my first year students this year, in one of these SAGES classes I was talking about, the thing that we noticed is that the college students gravitated very quickly to talking about the technology and not the product, or what was the need, if you will, that the marketplace is sort of asking for. And we would push them to the need question. It was interesting to see their reaction because as they would get feedback from their classmates, instead of listening to the feedback and thinking about how that would impact their design, they would defend their choice of technology selection. And so we had to work to get our students to listen and not defend, and to use those opportunities of getting feedback to ask questions rather than make a statement. And so again, I think those are some things that you can do as well as, there's a book by Kirk Carlson, and Kirk Carlson used to be the director of SRI, and SRI, if you don't know, is the company that came up with the original computer mouse and Siri. I bet a bunch of you have Apple phones, iPhones. So Siri was developed by SRI and then licensed to Apple. So Kurt has a book on innovation, and it teaches a methodology called NABC, which is need, approach, benefit, and competition. And it's a great book. I think if you read chapter 5 of that book and created your lesson plan around that, it would be fantastic. I can give you my card afterwards. Yeah, that'd be great. Yeah.
Thank you. Doug Reiner, Indiana University. I'm a process guy and very visual. Excuse me. Can you describe, do you use a project management, or how do you decide when someone walks in the door? Is this already been done? Do they partner with someone else? How do you track the progress? You've got some data and some analytics. I was curious on how you bring that in.
So, I mean, if you guys are interested, we have two students here, Zyla Foxlin and Tyler Eston. These are two students who are here at the Consumer Electronics Show. Both of them have startups that are doing some really interesting things. They're both second-year mechanical engineering students, and so maybe they can share with you some of their experiences about the interactions they've had with the staff to help them refine their ideas. One of the things I talked about was a program we have called LaunchNet, which is basically professional staff who take these students who want to be entrepreneurs and really coach them into what is the product, you know, what's the need that you're looking at. So if you want you guys, if we get a microphone up here for either Zyla or Tyler, that might be good. Who's good? Okay, go ahead and yell.
So, to answer your question specifically, I work a lot with the system, how to implement it, and so the first thing that my co-founder and I did we're both engineers, and we decided our third hire was going to be a student from the Cleveland Institute of Art. So I went straight to one of the staff members at ThinkBox, who I knew was a graduate of the Cleveland Institute of Art, and I said, hey, I have this startup, this is what we do, we're a tech toy company, so we need a really good designer. Can you hook me up with an industrial designer? And he goes, sure. He sends a couple emails, and a week later I'm interviewing designers from the Cleveland Institute of Art. So that was a really valuable thing, and we ended up interviewing a kid who had interned at Fisher-Price, had interned at Mattel, and he ended up being a really good fit. So that experience, and then working with LaunchNet, and we decided not to take on a business person yet, but instead just take the mentorship out of LaunchNet. I don't know.
Yeah, Tyler.
Additionally, like with ThinkBox itself, as we're also both student workers there who've helped facilitate people coming in and working on their projects. When they come in, we have basically like a little sign-in system. So we ask them, you know, where they're from, why they're here, how can we help them. And as actual student workers, we're not the people who actually will come in and do the work for them, but we'll show them how to use the equipment. So when you have business people who come in from the community, or you have other students from other universities, or even our own, the system is kind of the same. We'll help them with equipment that needs certification that we need to teach them how to use. And with other equipment, we'll basically just take a more hands-off approach, show them how to use it, and then let them do what they want.
Yeah, back here. You, yeah.
This is on a different subject, so go ahead if you.
That's okay, go ahead.
With so many people involved and so many resources involved, how do you handle intellectual property issues?
So that's a great question, and basically what we say is it's an IP-free zone, that the students' ideas are theirs. So Zyla and Tyler, for example, they own it. You know,
interestingly, my project was entirely funded in the beginning by a grant from ThinkBox, and then I used the IP Venture Clinic at Case. They did all of the patent paperwork for me, and yet I still own all of the intellectual property. It's completely in my name.
For graduate students and faculty, it's a little bit different because they're being paid either under sponsored research grants or some other type of funding. A faculty member, for example, has a contract with the university that they're sort of doing their job. But for students, particularly students at the undergraduate level, it's theirs. Yeah, in the very back. Yeah. Yeah, they just come in and use it. Like these guys and others would train them, make sure that they're going to be safe on it. We'll give them a little bit of advice and things like that, but yeah. No. They're just paying for consumables, basically. Yeah. And, you know, but of course, if one of our staff members have particular expertise about a technology, they may very well say, you know, you may want to try and do it this way. And that's just being a good citizen. You know, that's just being, you know, so there's a lot of that goes on. And there's people who will be in the ecosystem who will just say, hey, you guys might want to try this a little bit different way. You know, we've tried that before.
But both of us actually work on the weekend shifts, and so we spend the majority of our time actually helping community members. And so we get paid, pay off those student loans, to help community members, but all that they ever have to pay for is if they purchase like wood or plastic from us that they're going to use in our laser cutters and our 3D printers. So does that answer your question?
Well, thank you all very much for not only your interest, but also the opportunity to talk here at CES.